Imagine the most advanced construction project on Earth today. The Burj Khalifa, the Large Hadron Collider, a nuclear aircraft carrier. Each required thousands of engineers, computer modeling, and years of precision planning. Now, imagine building something even more permanent, something that would outlast empires, religions, and even entire languages, something that would still stand 5,000 years later. Now, here's the contradiction. A civilization that left behind no written language, no wheels, no iron tools, and no mortar somehow dragged massive stones across miles of open country and assembled them with mathematical precision. Not one stone, not 10, 83 massive blocks, some weighing as much as a fully loaded passenger jet. And here is the question that has haunted archaeologists for centuries. Did we completely misunderstand what our ancestors were capable of? Or did they have help from somewhere else? Forget everything you think you know about Stounhenge, because the real story is far stranger than any legend.
Stounhenge sits on the flat expanse of Salisbury Plain in Wiltshire, England. It is not a single structure, but a series of constructions, built, rebuilt, and modified over more than 1,500 years. To put that in perspective, that is longer than the time between today and the fall of the Roman Empire. But here is what makes this site genuinely unsettling. The earliest phases of Stounhenge began around 3000 BCE. That is 500 years before the Great Pyramid of Giza. It is 1,000 years before the first Olympic Games. And yet, the engineering required to build just the first stage would challenge modern construction teams even today. Over the course of this documentary, you will discover how these stones were transported without wheels. You will learn why the mathematical layout of Stounhenge aligns with celestial events that would not be formally documented for thousands of years. You will see the evidence that suggests the builders understood acoustic physics, structural engineering, and geology in ways that should not have been possible. And by the end, you will have to ask yourself a deeply uncomfortable question. Are we the most advanced civilization to ever live on this planet? Or have we simply forgotten what came before?
Let us begin in 1923. A British geologist named H. Thomas was examining thin sections of stone under a microscope. He was trying to solve a mystery that had puzzled antiquarians for centuries. Where did the smaller stones at Stounhenge actually come from? These were not the massive sarsen blocks that everyone recognized. These were smaller, darker stones, now called blue stones. And Thomas made a discovery that changed everything. Under his microscope, the mineral structure of one Stounhenge bluestone matched exactly with rock formations found in the Preseli Hills of southwest Wales. That is a distance of 140 miles. Think about that. Someone over 4,000 years ago extracted massive stones from a quarry in Wales, transported them across mountains, rivers, and forests, and reassembled them on a flat plain in southern England. But here is the problem. The bluestones weigh between 2 and 4 tons each. That is roughly the weight of a modern SUV, and the builders had no trucks, no paved roads, no metal tools for carving wheels. Even today, moving a 4-ton block of stone over rough terrain requires heavy machinery, specialized trailers, and engineered roads. So how did a Neolithic society with none of these technologies accomplish the same task? Some researchers have suggested transport by sea, using rafts along the Welsh and English coastlines. Others argue for an overland route, using wooden sledges and rollers made from tree trunks. But both theories have the same fatal flaw.
Experimental archaeologists have tried to replicate these methods using authentic materials and techniques. The results were disastrous. Teams of dozens of people could barely move a single stone a few hundred meters in an entire day, moving 80 stones over 140.
Now, let us look at the larger stones, the sarsen blocks. In the 1950s, archaeologist Richard Atkinson began the first systematic study of how Stounhenge was actually constructed. What he found would haunt him for the rest of his career. The largest sarsen stones stand up to 30 feet tall. That is the height of a 3-story building. They weigh between 20 and 30 tons each. And here is the engineering nightmare. The builders did not just place these stones upright, they shaped them. Using only stone hammers and antler picks, they carved mortise and tenon joints into the tops of the uprights and the bottoms of the horizontal lintels. That is the exact same joinery technique used in fine woodworking, but applied to stone. Think about the precision required. The tenon had to fit into the mortise with almost no gap. If the fit was too loose, the structure would wobble. If too tight, the stone would crack during assembly. Modern engineers building with stone today still struggle with this problem, and they have diamond-tipped cutting tools and laser levels. Now imagine doing this with a rock hammer. But here is the real impossibility. The sarsen stones did not come from Wales. They came from local sources, yes, but the closest source of sarsen is at Marlborough Downs, about 20 miles north of Stounhenge. That is closer than the bluestones. But the weight makes it worse. A 30-ton stone on a wooden sledge dragged across chalk grassland creates so much friction that the wood would ignite from the heat. Experimental archaeologists from University College London tried to replicate just the transport of a single 10-ton stone using Neolithic methods. After weeks of effort moving the stone less than a mile, the wooden sledge had to be replaced 3 times. The team concluded that moving all the sarsen stones would have required cutting down every tree within a 10-mile radius just for replacement parts. And yet there was no evidence of widespread deforestation around Stounhenge. So either the builders had a technology we have not discovered, or they found a method so clever that it has left no trace. What if the answer is not about moving stones at all, but about moving something else?
In 1960, an astronomer named Gerald Hawkins did something no one had thought to do before. He fed the coordinates of Stounhenge into an early IBM computer, not to study the stones themselves, but to study their shadows. What the computer revealed was astonishing. Hawkins discovered that Stounhenge was not just a monument, it was a calendar. A precise, working astronomical computer built from stone. The heel stone, the one that stands apart from the main circle, aligns perfectly with the rising sun on the summer solstice. But that is just the beginning. Other alignments mark the winter solstice, the equinoxes, and even the major and minor standstills of the moon, a cycle that takes 18.6 years to complete. To detect these alignments, the builders would have needed to observe the sky continuously for multiple generations. They would have needed to record positions, track movements, and predict future events, all without a written language. Here is the problem. The precision required for these alignments is not rough, it is not approximate. The summer solstice sunrise aligns with a gap between stones that is less than 1 degree wide. That is about the width of your thumb held at arm's length. Achieving that alignment means the builders had to survey the landscape, level the foundation, and position the stones with an accuracy that rivals modern theodolites. How did they do it without geometry, without trigonometry, without even a written number system? Some researchers have suggested that the builders used wooden stakes and ropes to create circles and sightlines, but that method cannot account for the lunar alignments, which require understanding that the moon's rising point shifts along the horizon over nearly 2 decades. You cannot observe that in one lifetime. Which means the builders were not just engineers, they were scientists. And they were passing knowledge across generations with no written records. So what else did they know?